retrying HTTP requests using a decorator in Python. When working with HTTP requests in Python, handling transient errors gracefully is crucial for creating robust applications. A common pattern to address such issues is to retry a failed request a certain number of times before giving up. This can be elegantly implemented using decorators, which allow you to modify the behavior of functions without changing their actual code. Here's a step-by-step guide on how to achieve this using a decorator. Understanding decorators. In Python, a decorator is a function that wraps another function or method, allowing you to modify its behavior. Decorators are commonly used for logging, access control, instrumentation, and, in this case, retrying operations. Key concepts. 1. Retry logic. This involves defining how many times to attempt the request before failing and the conditions under which a retry should be attempted. Common practices include retrying on specific HTTP status codes, like 500, or exceptions. 2. Delay between retries. It's often beneficial to introduce a delay between retries to avoid overwhelming the server or network. This can be a fixed delay or an exponentially increasing delay. Steps to implement retry logic with a decorator. 1. Define the retry decorator. Create a decorator function that will handle the retry logic. This function will accept parameters for the maximum number of retries and the delay between retries. Wrap the target function to catch exceptions or check HTTP response statuses. Retry the request if an exception is caught or a specific status code is received, up to the specified number of retries. 2. Handle exceptions and status codes. Inside the decorator, use a loop to attempt the request multiple times. Implement logic to catch exceptions that indicate transient issues, like network errors, or check for specific HTTP status codes that suggest retrying. 3. Introduce delay. Use a sleep function to wait between retries. This can be a fixed duration or a more sophisticated strategy like exponential backoff, where the delay increases exponentially with each retry attempt. 4. Apply the decorator. Use the decorator to wrap functions that perform HTTP requests. This way, you can easily apply retry logic to multiple functions by simply adding the decorator. 5. Test and fine-tune. Make sure to test the retry behavior under various scenarios, including network failures and server errors, to ensure the decorator works as expected. Adjust parameters like the number of retries and delay duration based on your application's requirements. Benefits of using a decorator for retry logic. Separation of concerns. Keeps the retry logic separate from the business logic of your functions. Reusability. Apply the same retry mechanism to different functions by using the decorator. Flexibility. Easily adjust retry parameters, e.g., number of retries, delay, without modifying the core function logic. By following these steps, you can effectively manage transient failures in your HTTP requests using a decorator, making your code more robust and easier to maintain.